Hey, good morning. Calculus 1. We're trying to learn about limits. I got you started there. When you start doing limits in 2.2. Remember, section 2.1 was what is calculus. So that's cool. But 2.2 is you start doing limits numerically and graphically, and then in 2.3 you start doing these limits analytically. I like this question. I created this graph, crazy function. So this is like a 2.2 question where we're going to try to do these problems graphically. And I might have more to do here for you on this video or another one quick. But so this is a typical kind of question in 2.2 in the homework. Also on my test or quiz, I like a question like this. Again, there's 8 questions here actually. And you're observing this function, and the question is, this question is, what's f of -3? What's f of 1? What's f of 3? So, those are kind of pre-calculus questions. Those are, when x is -3, what's the y value? When x is 1, what's the y value? And then the new calculus questions are these limit questions. So, what is... As x gets really, really close to -3, what y value are we getting really close to? Which is a different question. Might have the same answer in some cases, different answers in a lot of cases, but it's a different question. The limit question is different than the function question. So here we go. Let's take a look at this. So what is f of -3? I find the x value -3 and I try to find where the y value is defined. I think it's colored in there. I think it's defined right there, and that y value is a 1. Remember, the answer to the function values, we're looking for y values, and the answer to these limit questions is always a y value. Some students get a little confused. They'll say, oh, when x is -3, the answer is -3. Well, wait a minute. The answer is the y value, which is 1. So, cool. That was easy. Now, let's stay here. Let's try to do the limit as x approaches -3. As x gets really close to -3, we're not on that dot. We're up here, we're on the function, and x is getting close to this -3 value, and when it does, it's getting close to this y value. Even though it never gets there, even though there's a hole, it's not defined there. It is defined there at 1. As x gets really close to -3, the y value it gets close to is 2. So the limit is 2. Let's try this one. When x is 1, what's the y value? When x is 1, what's the y value? Well, there's a big open circle there at 4. That's not the defined y value. It looks like it's the colored in y value at 5. I think when x is 1, the y value is 5. What's the limit as x approaches 1? Well, we're approaching 1 from both sides. These are two-sided limits, these questions. And so we're approaching 1. When you do approach from that side, it looks like you're approaching that y value of 5. And when you're on the function approaching from this side, even though you don't get there, you're approaching a y value of 4. So that's 2 different y values. And I think I tried to barely taught this in the last video. When the limit question does not have a one unique answer, when you think there's 2 or 3 or more answers, there's no answer. And the official answer is the limit does not exist. When the left and the right don't match up, when they're not approaching a single y value, the limit does not exist. We write DNE. Cool. Let's move on. This is the most boring question up here. I'm sorry. Sometimes the boring ones are so easy they throw students off. But look, at 3, there's nothing interesting happening. When x is 3, I think we're just on this beautiful continuous function. There's a lot of places where we have discontinuities, and that's another topic coming up here in calculus. That's section 2.4. But and when we explore these questions, the discontinuities are the interesting places. That was a hole, that was a discontinuity. This was a break, that was a discontinuity. There's an asymptote over here at 4 coming up. That's an interesting thing. So here's this one uninteresting question. When x is 3, the y value is 2. And what about the limit as x approaches 3? As x approaches 3, I think it approaches this y value of 2. I mean, that's not a hole, that's not any, it's just a place on the function. So I wanted to throw a boring one in there to throw you off. All right, what about over here at 4? The question is, when x is 4, what's the y value? And what you see there is a vertical asymptote. And when you have a vertical asymptote, there is no y value. I mean, there's no colored in dot. The function's not allowed to cross a vertical asymptote, so there's no defined y value. So technically, the y value doesn't exist, but we use that does not exist language for a limit. For when a function is not defined, when that function value is not defined, we use the word undefined. So it's undefined. At 4, the function is undefined. And what about the limit as x approaches 4? Well, this is kind of a funny one. If you're approaching 4 from this side, you're approaching 4 from both sides is what that question is. But when you work on one side and you're approaching 4, looks like you're headed up toward, and this is what happens at an asymptote, you're headed up toward positive infinity. Now that's approaching 4 from the right. As we approach 4 from the left, we're on this function and we're headed, getting closer to 4. I think we're headed down to this, toward this, the bad place, negative infinity. So coming from the left, I think we're headed to negative infinity. Coming from the right, we're headed toward positive infinity. You know, we had that discussion earlier. When we're coming from the left, when we're coming from the right and we're coming from the left and we get 2 different answers, we say the answer to this limit does not exist. So I think that's what we say here. Does not exist. DNE. Why does not exist? Because the left and the right limits didn't match up. There were 2 different answers. Now, when we head into 2-4, there's some topics, but one of the topics is one-sided limits. And so while we're here, let's just have a little discussion here, a little preview of this. This is easy to tell you about. But if I do this question, what's the limit of this function? We'll use this picture as x approaches 4, and I put a little negative sign on the back side of the 4. Then this means I'm approaching 4 from the left. This question says, what's the limit as x approaches 4 from the left? This is a one-sided limit. They haven't been introduced yet in the text. Here, they're introduced in section 2.4. I'm introducing them now. This is the terminology, this is the notation for a one-sided limit from the left. And now I hope I don't confuse you too much, from the left. But I might argue with the book a little bit here. See, when your book thinks the answer is infinity, they start off by saying that doesn't exist. And I kind of get it. If it's headed toward infinity, it doesn't. The y value doesn't exist. It just, we're headed toward infinity. Infinity is not a number. It's more of a concept that it keeps getting higher and higher, keeps going, or keeps getting lower and lower to negative infinity. So it does not exist. Yeah, I get it. But I want to know. I kind of reserve does not exist for when the left and the right don't match up. When the left and the right are 2 different answers, that does not exist. And when the graph is headed toward infinity, I want to know that. I want to know that as information. And the book changes their mind. They start off by saying if the answer is infinity, it doesn't exist. Then they get to where they say you can tell me the behavior of the graph, and you can answer infinity. So they sort of change, they do what I say. And so let's just start by saying, as I approach 4 from the left, looks like it's headed down to negative infinity, and that is an answer that I want to write down, negative infinity. If I had this question, what's the limit as x approaches 4, and I put a little positive sign on the back side of the 4, that means I'm approaching from the right. So I'm on this function, and I'm approaching 4 from the right. And we have this long discussion. As we approach 4 from the right, we're headed up to positive infinity. So again, I feel like these two one-sided limits have answers. The limit as we approach 4 from the left is negative infinity. The limit as we approach 4 from the right is positive infinity. And that's because they're different, that's why I said this one does not exist. You know, if they were both headed up to positive infinity, which can happen, then I think I'd like you to say positive infinity here. Even though, again, at the beginning, the book might tell you it does not exist. I hope you see my point. You know, back to this 1 here. This limit, I'm not going to write anything down, but as x approaches 1, I could use the notation, as x approaches 1 from the left. From the left, as x approaches 1 from the left. Even though it doesn't get there, there's an open hole there, it is approaching a y value of 4. From the left, I think the answer is 4. As you approach 1 from the right, I believe it's approaching a y value of 5. Because the left and the right didn't have the same answer, one was 4, one was 5, this answer does not exist. This video is getting a little long. It's only one problem with a lot of cool questions. I introduced the idea of the one-sided limit. We'll get back to that a little bit. But one more idea. We don't really do these limits until later in the book, later in chapter 3, to tell you the truth. What's the limit as x approaches infinity on this function? And what's the limit as x approaches negative infinity? Now, these are different questions. These are different questions. Like I said, I don't think you'll see any of these in the book, but it's a very visual, graphical idea. As x approaches infinity, can you tell me what y value we're approaching? And it's hard to tell what's going on here, but sometimes when the graph bends like this, it looks like a lot of graphs approach the x-axis without ever crossing or touching the x-axis. In other words, the x-axis acts like an asymptote. So, a horizontal asymptote. So that was my intent in this picture. Therefore, as x goes to infinity, what y value are we approaching? And I think we're approaching a y value of 0. As x goes to infinity, I think the picture indicates we're approaching a y value of 0. As x goes to negative infinity, that's way over here, looks like it's just kind of headed down. That arrow means it keeps going down. It doesn't look like it's approaching any asymptote. There's no indication it is. So what y value is it approaching? By the way, it could turn around and go back up, but I should include that. So if I'm going to ask you this question, I think this is headed down, headed down, headed down. What y value am I approaching? As x goes to negative infinity, I think I'm approaching negative infinity for a y value. But these are, I don't know. These won't show up in the book. They do these limits as x approaches infinity up in chapter 3. But they do this asymptote limits that approach infinity in section 2.5. So we got a little bit of everything going on here, trying to get you used to all kinds of limits. All right, thank you for listening. Do some homework. I'm going to do some more in 2.3. I'm going to do some more analytic limits here next.